Hello everyone. After discussing the derivation of the equations of motion, we'll be discussing the problems that are associated with it, approaching the problems related to the equations of motion, how to approach them. Uh, in order to do that, always keep in mind that the equations of motion deal in constant accelerated frame. That is, the acceleration remains constant. Now there is acceleration actually. But what if the acceleration is absent? Okay, a is equal to 0. How do the equations of motion change? Now consider the first equation of motion. V is equal to u plus at, a goes to 0. So V is equal to u. Okay, the initial and the final. Obviously the velocity isn't changing. Second equation, again a goes to 0 and you are left with s is equal to ut. Now u is nothing but v, as we have seen in the first case, right? So vs is equal to vt, or s is equal to ut, or v is equal to s by t. That is just the formula for speed without acceleration. Now v square is equal to u square, or v is equal to plus minus of u. V is equal to u modulus wise for the third equation. And for the fourth, a goes to 0, you have the s nth is equal to u. Means is it dimensionally correct? Because s nth is the displacement in 1 second and u is the speed. Yes, obviously it is dimensionally correct, because s nth is the displacement in the nth second. Now nth second means it goes from n minus 1 to n, isn't it? That means the difference in time is 1 second. So s nth is the displacement in 1 second. And what is the displacement in 1 second? Displacement in 1 second is just the speed. Okay, so displacement in 1 second gives nothing but the speed, and that is why this is dimensionally correct to u, and the entire equation is dimensionally correct. So whenever there is a case of uniform accelerated motion, we consider the equations of motion, else the equations of motion need not be considered. Now let's take an example for your better understanding. Suppose an object moves in a way such that it increases its speed from 10 meters per second to 20 meters per second while it has covered a distance of 50 meters in doing so. Okay, calculate the rate at which it accelerates. Now we need to find the acceleration, the rate at which it is accelerating. Now initial speed has been given, that is 10 meters per second, and the final speed also has been given. It increases to v, that is 20 meters per second, and the distance that it covers during that increase in speed is 50 meters, and we need to find the acceleration. Now u, v and s, all these are given, right? We need to find the acceleration. Now what is the formula that we can use? Which equation? We have four equations of motion. The first equation of motion, u v is equal to u plus at, but t, is it given? No, it's not been given. So the first equation, okay, we'll see to that. But what about the second equation? No, again t is available over there, but it's unavailable in the question. Now in the third equation, v, u, a, v, u and s has been given. A has to be obtained, so we can use the third equation directly, isn't it? V square is equal to u square plus 2as. So v, you just substitute the values and you get 400 equal to 100, or 400 minus 100 is equal to 100a. So you find the acceleration, that is equal to 300 by 100, which is equal to 3 meters per second square. Seems easy, isn't it? It's directly related to the formula. Some of the questions that you will come across, they will be given directly, the values will be given, and you just need to put the formula and obtain the answers. Okay, now how to approach the s nth problems? Okay, the displacement in the nth second. The displacement is usually to be found in some nth second, that is nth can stand for fourth, fifth, third, second, first, 10th second, etc. With other things such as the initial velocity u, the acceleration a, and the n, the nth that we are considering, the n. These things will be given, and you just need to find the displacement in the nth second. Let's consider an example for your better understanding. An object initially moving at a speed of 5 meters per second accelerates constantly at 2 meters per second square, right? Calculate its displacement in the 10th second, right? Now 10th second means s 10th is to be obtained, okay, where n is equal to 10 over here. right? So you have the initial speed, that is 5 meter per second square, and the acceleration 5 meter per second, and acceleration at 2 meter per second square. So you just need to put the formula, that is s of 10th is equal to u, that is 5, plus a by 2, 2n minus 1, a is 2 and 2n means 2 times of 10. Now keep in mind that when you are multiplying those things, keep them in brackets so that you do not confuse them. Most of the students do that kind of mistake, so kindly take care of that. So 2 and 2 gets cancelled out, so 5 plus the bracketed term 2 times of 10 is 20 minus 1, that is 19. So 5 plus 19 is equal to 24 meters. So that is the distance it has traveled from t is equal to 9 seconds to t is equal to 10 seconds. That means the 10th second. Okay, so in the 10th second it travels 24 meters. Now if I change the question, suppose calculate its displacement after 10 seconds, means right when the what if the question changes like that? Okay, right when the time is 10 seconds, what is its displacement? Now you have the initial speed, you have the acceleration, you have the time now to be equal to 10 seconds, not that. So this is not the displacement in the 10th second, right? So the formula we have this, we can either use s is equal to ut plus half its square, or we can use v square is equal to u square plus 2s, but v is not given the final speed, right? At the 10th second you do not have the final speed. So the first the previous formula, obviously s is equal to ut plus half its square. So s is equal to ut, all those values have been given, 2 and 2 cancel out, so 50 plus 100 is what we get, which is equal to 150 meters. Now that means if the starting time is taken to be 0 seconds and the final time is 10 seconds, obviously with the initial speed of 5 meters per second, it covers 150 meters at an acceleration of 2 meter per second square. Now from t is equal to 9 seconds to t is equal to 10 seconds, we had obtained the distance, that is s 10th is equal to 24. So the rest of the distance is obviously 126, that is 150 minus 24 is 126, that is from time 0 seconds to 9 seconds. Now let's check. Okay, let's check if it is correct or not, if it is coming out to be 126 or not. So what is the time difference over here? 0 seconds to 9 seconds mean time is 9 seconds, initial speed is 5 meter per second, and acceleration is 2 meter per second square. Now we have a range of time over here, that is 9 seconds. So we need to find the displacement, that is equal to ut plus half its square. U is 5, t is now 9 seconds, so 5 times of 9 plus half into a is 2 multiplied with square of 9, so 2 and 2 cancels out, 5 times of 9 is 45 plus square of 9 is 81, that adds up to 126 meters, which is absolutely accurate. So 126 meters in both the cases that we see over there are correct. Now one more thing that I can say is also the final speed at t is equal to 9 seconds. Let's treat it as the initial speed for the next 1 second. Next 1 second means from 9 to 10. Okay, the final speed at 9 second, okay, can be treated as the initial speed for the next 1 second. Next 1 second means from 9 second to 10 second, means the 10th second, right? So you have the initial speed there, you have the time there. Okay, we need to find that final velocity now at the end of 9 seconds. Okay, so let's try that. V is equal to u plus at. U, we have it 5 meter per second, plus a is 2, obviously, multiplied with, now time is 9 seconds. Okay, so 5 plus 2 times of 9 is 18, so that equates to 23 meter per second. So that is the speed it achieves when it has when the time is t is equal to 9 seconds. Now taking this speed, that particular speed that we obtained over here, 23 meter per second, taking that to be initial for the next 1 second, that is from 9 second to 10 second, we will find that displacement. Obviously we know that displacement, that is 24 meters, but let us check. Okay, so this is just to let you know that everything is that we are doing is completely correct, and the physics of it is understood in a better way. So time is 1 second, 10 minus 9. Initial speed now is 23 meter per second. Acceleration as such is 22 meter per second square. We put it in the formula s is equal to ut plus half it square. So instead of t, just we have substituted 1 over there because the time is 1 second. So it is 23 plus the half get cancelled out with 2, and we are left with 1. So 23 plus 1 is 24 meters, which is absolutely correct and absolutely accurate. So we took two approaches. First is using the SNF, and the second we used two steps, that is we found out the initial final speed first, took it as the initial speed, and then we substituted it in S is equal to ut plus half a t square. So there are various forms in which you can approach different problems, right? Some are directly given, some have to be obtained indirectly, where the values, some of the values may not be given, and you will have to find the for first one value, then use it for the next value, final answer. So that is how we approach. So keep practicing more problems, okay? They'll be really helpful to you in understanding the concept of kinematics and physics, which will help you, which will make it easier for you. In the next video we will be doing some graphical analysis and the problems related to that. Till then, thank you, have a nice time, goodbye.